So this is practice 1, series circuit number 1. What I'm going to show you is how to solve series problems using Ohm's law, as well as using drawings and graphing and showing your algebraic work. So what we are going to start with is, what do we have? We have here a battery that has a voltage of 9 volts, and we know that because once it leaves the positive terminal, it already has 9, and we know that the white circles in our simulator shows us the voltage of the amount of voltage there is in that particular point. And we have 2 resistors, so this will be resistor 1 and resistor 2. And we know from the problem that the resistor is they have the same resistance. So that means this number is going to equal, so this number will equal this number. All right, so I'm going to erase that for a moment. We also know that the rectangle will tell us the current. So this will be the current, and it will be our I. The total current in a series circuit, it's going to be the same throughout the entire circuit. So wherever we put this ammeter, it will always read 0.45 ammeters because it's given to us here. So now let's go ahead and fill in what we do know. We do know that our battery voltage is 9 volts because that's the amount of volts leaving the positive terminal. And when it enters it, it's 0. So there's 0 volts when it enters the battery because all the charge carriers are they're low on the voltage. All right, let's go ahead and draw this. So we're going to start with our battery, and we're going to draw our wires. Instead of drawing the light bulb as a circle like we would normally do, I'm going to draw it as a resistor because that's what it is. It's also a resistor. And then everything else will just be the same. So the ammeter will be here, and we're going to draw it. There we go. So in showing our work, we know that this is 0.45, and we know that the battery has 9 volts. An important part is that we're going to draw the current direction. So the current is going to flow out of the positive terminal through the resistors and then back to the negative terminal. So this will show us the current's direction. Now, to find out what the total resistance is, so to find out the total resistance, we're going to take our total voltage and make it equal to our total current times our total resistance. And since we have 2 of the 3 numbers given to us, then we can go ahead and solve for the total resistance. So, whoops. So we have 9 volts is equal to 0.45 amps times total resistance. And when we isolate for total resistance, we get 9 divided by 0.45 will give us 20 ohms. So this will be 20 ohms. Next, we want to write down what we have. So as we talked about in class, we have that this will be the voltage drops. So these two we're looking for the voltage drop of each resistor, and they need to add up to 9 volts. So here, since we're going to go back to our picture, we have 9 volts after it comes out of the battery, and then it goes to 9 volts. There's still 9 because it hasn't gone through anything yet. Then it's 9 here. Then it drops down to a number. Since they have the same resistance, we're just going to know to take 9 divided by 2 because there's 2 resistors, and we'll get 4.5. So now we have 4.5, and we'll have 4.5 before the other resistor, and we know that it'll drop 4.5 as well. So that'll be 0. So 4.5 minus 4.5 is 0. So we have 4.5 volts and 4.5 voltage drop. And so this will be 0 and this will be 0. Now, in a series circuit, the current is the same throughout the entire circuit. So wherever we put this ammeter could go here, it can go here, it can go anywhere, and it'll still read 0.45 amps. Because there's really only one direction for the charge to go through. So that's why it's going to be the same. All right. Now we need to find out the resistance. Once we find out the resistance for one, we can find it for the other because they are the same resistance. All right, so to find that out, we are going to take, there's two ways. So way number one would be to use Ohm's law. So the voltage for, let's say, 2 is equal to the current times the resistance. So for the voltage drop, it was 4.5 volts, and then the current was 0.45 amps times a resistance that we don't know yet. And we divide it by the current value, which is 0.45 amps. And we are going to get 4.5 divided by 0.45 is going to be 10 ohms. And the other way we can do it is, since we know that the total resistance is equal to R1 plus R2, and these two are going to be equal values, then we'll know that 20 ohms is going to equal to R because they're the same. So now we divide by 2 and we get 10 ohms is equal to the resistance. So we can fill in that this is 10 ohms and this is 10 ohms. All right, now graphically, what we're going to show is the voltage drop. It's kind of like the travel story of a charge carrier as it goes through the circuit. So we are going to label the part of our circuit. We'll start with the negative terminal. We'll start with A, and then B will be after the battery, and it goes through, and then we'll just label before and after all components. So before and after, before and after. And we'll go before and after here. So we have A, B, C, D, E, F, G, and H. And then for the voltage, the highest we'll go is 9, and the lowest we'll go is 0. So we'll do 0 here, we'll write 4.5 here, and we'll write 9 here. So at point A has the same, so in our diagram, we have A right here, and it's at 0. So we're going to say it's at 0. At B, it goes up to 9. So at point B, it's at 9. Then when we go to C, we see that it's still 9. And D, it drops 4.5. So it goes through the resistor. So what we see here is resistor 1. Next, at point E, it's still 4.5. So it stays at 4.5. Then at F, it goes down to 0. And G and H are at 0 the whole way through. So that was resistor 1. This drop shows the drop for resistor 2. And this number should be equal to whatever it says in our chart, which it does. So that's fine. All right, so that is number 1. If you have any questions, make sure to email me or shoot me a text.